Linear inequality in two variables, so up to this point you've only done one variable, such as y is greater than x plus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. A solution of an inequality in two variables is an ordered pair, a point. So that would be something like x, y. So you have to have two numbers since there's two variables. That makes the inequality true. A linear inequality in two variables has an infinite number of solutions because there's a bunch of points that work on the line and in the shaded area. These solutions can be represented in the coordinate plane as the set of all points on one side of a boundary line. So our first unit, you guys did it on a number line where you like did open circle or closed circle and then drew an arrow one way. Do you remember this? Okay. This is like doing that, but instead of just having one variable like just x or just n, you have two, and so we get two-dimensional and we go to a graph. So the first one is just some practice with you, plugging in and seeing what solutions are. So which ordered pair is not a solution? Just like we tested solutions in one variable, we test it the same way. So we're going to start with A. -2 is x. -3 is y. Or sorry, not -3. 1 is y. Now plug in those numbers into the inequality. So instead of putting x, we'll put -2. And instead of putting y, we'll put 1. So it's -2. And in parentheses, we'll put -2. Plus 3 times y, so that's 3 times 1. We want to know, is that greater than 8? So that's I was trying to do a question mark. Here we go. Is that greater than 8? That's what we want to know. Let's think about it. Guys, what is -2 times -2?
4.
Okay, what is 3 times 1?
3.
Okay, so we have 4 plus 3. Is that greater than 8? Well, what's 4 plus 3? 7. Is 7 greater than 8?
No.
Heck no. So which one's not a solution? A, the one we just did. Because 7 is not greater than 8. It's less than 8, right? So it doesn't work. So we don't have to test any of the other ones because we know A was the right answer. That's nice. Now let's get to some graphing. I think this is so fun. And you guys are getting really good at graphing, which is good. So this is just adding two new things for you. The first thing is you got to figure out, will it be a dotted line or so is it going to be a dashed line or a solid line? Just like when we did inequalities in our first unit, if you see, so it's over here, if you look over kind of on this cabinet, on the green paper, if it's less than or equal to or greater than or equal to, it's a solid line, just like it was a closed circle. If it's less than or greater than, then it's like having an open circle, and so you're going to have a broken line, which is like dashed. And what that's saying is it does not include the points on the line when you have a dashed line, because it has to be either less than the line or it has to be greater than the line. You also have to shade, because it's saying, okay, everything either less than or equal to the line, or we flip it and say greater than or equal to. So the graph of a linear inequality consists of all the points in the coordinate plane that represent solutions. So everything in the shaded region, like on this one, it's everything in the shaded region, but not the ones on the dotted line. And the one on the right here, everything in the shaded region, as well as the ones in the solid line, because it does include the line. All points on one side of the boundary line are solutions, while the points on the other side that are not shaded are not. Okay, let's graph. We graph the exact same way as we've been graphing. Just don't maybe draw on the line just yet. So we do the slope. Let's get the starting point. And hello, what is my y-intercept, my starting point? My y-intercept, yep. Thank you. So that's the point 0, 4. Go ahead and graph that guy. And you don't have to worry about open circles or closed circles, just make your point. My slope is -1/2. So we know that goes up or down. If it's nice negative, the slope would go up or down? Down 1/2, which we go to the right first. So from your starting point, please go down 1, right 2. Our graph is scaled by 2's, but that doesn't matter since both the x and the y are scaled by 2's. And reverse it. Now, the inequality sign is y is less than. So since it's less than, it excludes. Will it be a solid line or a dashed line? Dash. It cannot include things on the line. So you're going to take your pencil and just put dashes through the points. It's important that you use a pencil when you're doing this. I can't tell you how many times students are like, solid line. And they're like, no, that's wrong. And they take their pen and they draw it. They're like, actually, that's supposed to be dashed, Miss Grant. So use a pencil. Yes?
Why are the circles closed?
So,
is it open or not?
You don't have to worry about closed or open circles because it's the line. Like, the line does it for you. Since we're making a dashed line, it's like having all open circles along that line. So dashed line is having like one open line almost.
If you're graphing inequality, will you ever have a solid line? Or is it always that?
You will have a solid line if it's greater than or equal to or less than or equal to. Because it could be equal to the points on the line. This one has to be less than the line, so it can't be the points on the line. Which is why we use dashed. Okay, now we shade. It says y values less than -1/2 x plus 4. Look at your y-intercept. Your y-intercept is at 4. Where are the y values less than? When we go up or when we go down? Down. So you would shade everything below the line. Make sure it's really obvious. You want to shade it really dark, that's fine. It's your pencil lead. Just make sure I can tell where you shaded, please. That's really it. Okay, so that's all we're doing today. Graph the line as you normally would, but make sure you figure out, okay, is it equal to or not? Because that decides dashed or solid. And then shade in the direction that makes sense based on, well, it's y is less than, so it goes down. If it helps you, you can think of like less than is lower. So shade below the y-intercept. You ready? You can move on. Okay, we have talked about these lines recently. When it's y and then a number, it's a special kind of line. What kind of line is it? Can you show me with your arms what kind of line is it going to look like? Flat. It's a flat line because it's got to go through y equals 2. And the only way that actually makes sense is like that. Another way you can think about it, this is the same thing as having y is, there we go, y is less than 0x plus 2. It's a slope of 0 because it's horizontal. The y-intercept is 2. So let's graph that like we normally would. So we're going to go to 2. And it'll be a horizontal line, but don't just draw your line yet. Let's think about whether it should be dashed or solid. It's y is less than. What should it be? Dashed. Cannot include the line. So make yourself a pretty dashed line. It's got to be horizontal because it's slope of 0. And there we go, hoi bucks. It tells us y equals a number is horizontal with a 0 slope. And it needs to be y values less than 2. We just did this. Here's 2. Which ways? Up or down? Which way is y values less than 2? Down. 1, 0, -1. So shade below. Less than is lower. We just got one more. And this one's in standard form. I'm going to teach you 2 ways how to do it. Whichever way you prefer best is fine with me, okay? So you will not offend me either way that you choose. Either way should be correct. Did I mark on those? Oh, whoops. Okay. Ignore the random point that's on the graph. That was an accident. So we're going to graph this line. 2y plus 4x is greater than or equal to 8. I personally feel like you can do this with x and y intercepts. I think solving for y is a little bit easier, but I'll do it both ways. Okay? So I'm going to first solve it for y. So rearrange it so it's in slope-intercept form, because I just think it's easier to do inequalities like that. So if we move the x term to the other side, it's positive, so you got to subtract it. I would give you 2y is greater than or equal to 8 minus 4x. Whenever you're doing this, though, I caution you, if you divide or multiply by a negative number, what do you have to do with the sign? Flip it. We talked about that first unit. We divide by 2. So it would be y is greater than or equal to 4, because that's 8 divided by 2, and then negative 4 divided by negative 2 would be negative 2x. So you could graph that line and do the shading on that. That's one option. And that's probably what I'll do. But you could also use your x and y intercepts, so I'll do that as well. So if this is your first option, option 1. Or x and y intercepts, so I'm going to do that. Sometimes, if you get like a decimal for your x and y intercept, then you should probably solve it for y and get it in slope-intercept form, because that's not going to be fun to graph. And I need you to be accurate. So if you get a decimal, don't use it. Do the other way. Option 2, get your x and y intercept. We did this, have done this a million times. Plug in 0 for y. And solve. Make sure you keep your inequality, though. And recall, if you multiply or divide by a negative, you've got to flip the sign.
How does that turn to negative 2?
It's not, it's positive 2. Oh, on the other one? Because you subtract 4x. And then you do negative 4 divided by positive 2. Negative 4x divided by positive 2 is negative 2x. Okay, get your y-intercept if you haven't done that.
But it doesn't really matter because you can graph both negative and positive. Like the first one, the slope is negative 2x.
Yeah.
On this one, it's positive.
No, that's not the slope. That's the x-intercept.
Oh.
Remember, we're reading the intercepts. Intercepts not the same as the slope. Intercepts are just 2 points. Slope is how it moves. It's a number in front of x, but it's not the intercept.
Oh, yeah.
Okay. So your intercepts, you get 2 points. 2, 0, and 0, 4. But you're going to have to pay attention to the signs as you graph it. So I'll do the intercepts way first. You'll see that we get the same thing. So we could graph 2, 0, and 0, 4. It's greater than or equal to, and so it would be a solid line. What that line? There it is. Solid line through that. And you're going to shade it. Let's see, it says greater than or equal to. Greater than or equal to 4. So which way is greater than or equal to 4? Above or below? Above. So you're going to shade everything above and kind of to the right of that line because it's greater than or equal to 2. You would get the exact same thing if you use the y equals mx plus v version. You could start at 4 and go down 2, right 1, down 2, right 1. It's a solid line, and then you would still shade above 4. So either way you want to do it, you get the same thing, same line. Okay. That's it. So